Well, our task is to find the critical points, the domain, the endpoints, and the extreme values, absolute and local, for this function y equals x squared times the square root of 3 minus x. Well, the domain for this function is the set x such that x is less than or equal to 3. If x was anything greater than 3, then we'd be trying to take the square root of a negative number, which is impossible. Now, let's find dy dx, and we'll use the product rule. So holding x squared constant and taking the derivative of root of 3 minus x, we have 2 times the square root of 3 minus x in the denominator. Then by the chain rule, the derivative of 3 minus x is minus 1. Now, plus, and now holding square root of 3 minus x constant and taking the derivative of x squared, we get 2x times the square root of 3 minus x. Next step, let's add fractions. And so our common denominator is 2 times the square root of 3 minus x. And so we have a negative x squared here, and multiplying numerator and denominator by 2 root x, we get plus 2 times 2 is 4. There's our x, and the product of root 3 minus x times root 3 minus x is 3 minus x. Now let's expand that, and so 2 square root of 3 minus x, and minus x squared, and plus 4x times 3 is 12x, and 4x times negative x is negative 4x squared. Now combining like terms, we have 2 root 3 minus x and 12x, and a minus x squared minus 4x squared is minus 5x squared. Now let's factor this numerator, and that will be x times 12 minus 5x, and in the denominator we have 2 times the root of 3 minus x. Now we have to set that dy dx equal to 0 and solve to find the critical points. Well, will you agree the values of x that will take this to 0 are x equals 0 or 12 over 5. So therefore our critical points are at x equals 0 or 12 over 5. Now one other thing, we have to find the endpoints. Well, this function continues to the left forever, but it does have an endpoint at 3. So I'm just going to EP for endpoint, and that's at x equals 3. So we've got our critical points, we've got our endpoint, and now let's look at the zeros for f prime of x. So this is f prime of x, and we have a 0 at 0, and we have a 0 at 12/5, and of course I'm going to look at this, also put the our endpoint of 3 here. Now we're checking out the slope. We want to know what the sign of the slope is in this interval, in this interval, and in this interval. So, in this interval, -1's in this interval. Let's look at this numerator. If x, because the denominator is always positive, so if x is -1, that'll be negative, but this will be positive, so our slope will be negative. Rate of change will be negative in this interval. Let's look at the next interval, and we'll pick a value like 1 in this interval. If x is 1, we have 1, this will be positive, this will also be positive, so the product of two positives is positive. Now let's look in this interval, or in fact let's just use the endpoint, and we can do that. We just need to find a sign, so I'll use 3. If x is 3, then this will be positive, but this will be negative. 12 minus 15 is negative. So now we know whether our slope is positive or negative. Next thing, let's evaluate x and f of x for the critical points and the endpoints. So we're talking 0, 12 over 5, and 3. And we want to know if we can find a local max, a local min, an absolute max, or an absolute min. So when x is 0, and now we're evaluating y for this value. When x is 0, we get 0. When x is 12/5, if you do the calculations, I come up with approximately 4.46. And when x is 3, we're going to get a 0. So now let's graph f of x. And here's our endpoint 3. Here's 12/5. And here is 0. And we have a negative slope going into 0, so we're going downhill. We have a positive slope as we move, x moves from 0 to 12/5. And then we have a negative slope as x goes to 3. So, and we know that when x is 12/5, our y value will be approximately 4.46. So there's our point, or points. Now, we have a local and ABS, absolute, min at 0, and it is 0. We have a local max at x equals 12/5, and it is 4.46. We have an absolute min at x equals 3. A local cannot occur at an endpoint. Now let's see if we've done everything we needed to do. We found the critical points, we found the domain, we found the endpoints, and the extreme values, absolute and local, for that function, so we're done.